Hey, so welcome to day 2 for transformations. Yesterday I left this off and I said to you, how could I figure what the equation of this quadratic is if I just went ahead and graphed this? All right, so ladies and gentlemen, if you listen, and actually this is kind of shifted just a bit. So let me go ahead and move this back over to where Mrs. Rose had it originally. What she had was 3 points, okay? And I had negative 1, 2, 3, 4, 5. So I had negative 5, negative 6. And then I had a 0, negative 7. And then I had 5, negative 6. And I said, geez, I want to do this as a quadratic on my paper, but I'm not really sure what to do. Well, guys, this is what you need to do. If you go to list in the graphing calculator, and in list 1, you type in negative 5, 0, and 5. And then in list 2, if you go ahead and type in negative 6, negative 7, and negative 6, and then go back to the calculator, and then type in stat, right arrow to calc, and then after I have the right arrow to calc, I want to press in the number 5, and number 5 is quadratic regression. And so when Mrs. Rose does that, and she hits 5, and she hits enter, what she gets is this information. She gets y equals ax squared plus bx plus c, okay? And then what she is told is that a is equal to 0.04, b is equal to 0, and c is equal to negative 7. So ladies and gentlemen, that means that my f of x is equal to 0.04 x squared minus 7. All right, so let's think about this. When I look at this, this is a vertical shrink of 400ths. There is no horizontal shift. There's a vertical shift down 7. My domain has been restricted from negative 5 to positive 5. My range has been restricted from negative 7 to negative 6. Okay? I have a decreasing interval from negative 5 to 0. I have an increasing from 0 to positive 5. And then my end behaviors, as x approaches negative infinity, y approaches positive infinity. As x approaches positive infinity, y approaches positive infinity as well. This also is an even function, and it does have line symmetry. Now, let's talk about a couple of other things, shall we? If Mrs. Rose wanted to make a little bit of a dimple, there's a couple of ways that you could do the dimple. Remember that if I'm talking about an exponential, I'm sorry, reverse that, strike it, sorry. If I'm talking about a rational, these are the 3 magic points for the rational if I'm talking about doing it here. But let's say Mrs. Rose wants to put it over here. Well, if my asymptotes are right here and right here, and all I want to do is I want to take this original parent function and I want to shift it over to here, well, that's easy, okay? Meaning not a lot of steps. F of x is equal to, well, I didn't change the a, did I? No, I didn't. I took the parent function and just shifted it. So there's the 1. Then I have the x. How many spaces did I move the asymptote? Well, let's see. I moved it 1, 2, 3, 4, 5, 6, 7. So I moved it right 7, and I moved it up 2. So there's my function. All right. So for part A, no, didn't do anything. For part B, no. Okay, what did I do? Right, shift 7, up, shift 2. So far, so good. What's my domain? Well, remember here it was a half, so this is just going to be 7 and a, that's right, 7.5. And remember this was 2, so 2 onto 7 becomes 9. Okay, what about my range? Well, this is a half, so that's 2.5. And this is 2, so 2 plus 2 is 4. All right, so far so good. This is decreasing. It's a decreasing interval. Remember, decreasing is defined by the domain. That's right, so I just rewrite the domain right here. Yes, it is 1 to 1. Okay. This does have point symmetry. It does have point symmetry. But because it's all the way over here, it is neither. Okay. And n behaviors as x approaches, what number? 7. That's right. Y approaches positive infinity. As x approaches positive infinity, y approaches 2. So that's if I have a rational. Now, what about an exponential? Well, what's kind of cool about an exponential is that you can basically use anything as a power. So let's say I wanted to use something tall and skinny, 5 to the power of x. Well, if I think about 5 to the power of x, 5 to the 0 looks like this. 5 to the first, 1, 2, 3, 4, 5. And 5 to the negative first is 1/5. So it kind of looks just like this. Whoops, a daisy. That's not very good, is it? But, you know, that's the problem when you work with a smartboard. Sometimes things just aren't as pretty as you would like them to be. So you'll kind of get my drift here if you kind of realize that this just kind of goes like this. And yours, of course, will be better. But, Mrs. Rose, I don't want it there. I want it to be part of a cheek. I want it to move over to here. I want it to move way over to here. All right, well, let's go ahead and just take that and move it way over to here. All right? All right, so what did we do? What did we do? We have 5 to the power of x, but we did a shift, didn't we? We shifted it over 1, 2, 3, 4, 5, 6. We shifted it left 6. And we shifted it up 1, 2, 3, 4. Up 4. Okay? Did we reflect it? Did we stretch it or shrink it? Or did we have any other thing besides the power function? No. That is the perfect point. Okay? So now, when Mrs. Rose thinks about this, and she puts it in her graphing calculator, and right now you can't see this, but Mrs. Rose can, okay? She puts it into the graphing calculator and she goes, oh, wait, that's perfect. That's exactly where I wanted it. So let's talk a little bit about the domain and the range, okay? First of all, we know that we don't have any reflections. We know that we have a horizontal shift left 6. We have a vertical shift up 4. And let's talk about our domain. Well, our domain right here is 1, 2, 3, 4. I'm sorry, wrong way. Strike that, reverse it. 1, 2, 3, 4, 5, 6, 7. So our domain is at -7, and it's going to go up to -6, -5 is my domain. My range, which is where Mrs. Rose was starting, is 1, 2, 3, 4, and a fifth. And it's going up to 1, 2, 3, 4, 5, 6, 7, 8, 9. It's going to right there. Okay? This whole function is increasing, and because I put a restriction on the domain, that's really simple. It is increasing from -7 to -5. Yes, it is 1 to 1. No, this one doesn't have any symmetry per se, and it is neither. Okay, because it's not reflecting across the y, and it's not here. Okay? All right, so what else do I have to answer? Oh, well, let's see. As x approaches -infinity, y approaches, what's it approaching? That's right, 4. And as x approaches positive infinity, y also approaches positive infinity. Okay? So, we talked a little bit about a rational. We talked about how to find the quadratic in the graphing calculator. And we also talked about a little bit about how to change an exponential. So, let me leave you with this. And this is something that could be used as a bonus. Let's go back to the eyebrow. If Mrs. Rose had an eyebrow here, that's just a standard square root, but Mrs. Rose has moved it right 2 and up 1, 2, 3, 4, 5, 6. So f of x is equal to x minus 2, and then put a plus 6, and then I restricted the domain. But what if Mrs. Rose wanted to put it here? What if Mrs. Rose wanted to reflect it over the y? Well, here's your hint. Let's look at the xy table over here. X is 2, y is 6, x is 3, y is 7, x is 1, 2, 3, 4, 5, 6, and y is 1, 2, 3, 4, 5, 6, 7, 8. Now let's look on this side. X is -2, y is 6, x is -3, y is 7, x is -6, y is 8. What do you think happened to get from here to here? And how would you show that on this function? Great question. Toodles. See you in class tomorrow.